Hi guys, so today we're going to be solving this question from the Woods and Raphael textbook. So it says consider a 5 by 5 spatial mass that averages the 12 closest neighbor of a point xy but excludes the point itself from the average. So this is the 5 by 5 spatial mass we have chosen. You can see the center pixel. It says it averages the 12 closest neighbor of the point xy. The point xy is at this point, and then we choose 12 neighbors for it. Find the equivalent filter H, G, or V in the frequency domain. So first we have to find the filter for the averaging mask in the spatial domain. This is simply the formula, is a mean filter, so it's basically 1 over 12. If this is the same thing as 1 plus 1 plus 1, 12 times all over 12 is the same thing. So now, in the end, we're going to get this. When you multiply 1 over 12 in order to convert this to its equivalent in the frequency domain, we're going to use a formula. This is the formula we're going to be using. It's simply x and y is the coordinate of a particular pixel. So that's why I have written out coordinates here in the green marker. In digital imaging, the center pixel is xy. If you want to go up, that's only in the y direction to y minus 1. You want to go downwards, it will be still in the y position, y plus 1. If you want to go in this direction, it will be x plus 1, y. This direction to be x minus 1, y. You want to go in this direction, first you go in the x plus y direction, then go in the y minus 1 direction. So you get the whole idea of what we're trying to say here. Just going to delete this. The value for the averaging mask in the spatial domain is 1 over 12. So, and then you substitute your values for x and y. So let's just get started. I'm going to first start with these 4 neighbors, 1, 2, 3, and 4. Those points are the coordinates 1, 0, minus 1, 0, 0, 1, and 0, minus 1. So we're going to be working with 4 coordinates. This, I forgot to mention, this summation basically just means sum up all the neighbors in the rows and sum up all the neighbors in the columns. That's just basically what this is saying. So now, for this point, it's going to be 1 over 12 times e raised to the power j 2 pi. For the first one, we have u. For the first one, we have u over m times, what is x? X is 1 in this case, plus y in this case is 0, so nothing remain of it. So this will just be the formula. The next value is going to be e raised to power minus j 2 pi minus u over m. This minus can cancel this, leaving this as something like this. Next, we have plus e minus j 2 pi to v over n plus e j 2 pi v over n. Now we're going to use an identity to actually solve this out. The identity is basically ej theta plus ej minus theta is equals to what? 2 cos theta. So we're going to use it to simplify this equation. I'm just going to scroll down a bit. At this point and this point, you can see here has negative, here has plus. So it's just going to be simplified as 1 over 12, 2 cos. This entire thing is going to be seen as the theta. So it will just be 2 pi u over m. Rather right side just plus 2 cos, in this case to be 2 pi, 2 pi v over n. That's simply the answer. If you want to simplify this more, it's just going to be 1 over 6 because 2 is going to factorize out cos 2 pi u over m plus cos 2 pi v over n. So this is the summation for the first neighbor. For the diagonal neighbors, that 1, 2, 3, 4. Those 4 points. We're going to be working with them. We're going to be 1, 1, minus 1, minus 1, 1, minus 1, and minus 1, 1. So if you evaluate, it's going to simply be, this is going to be the solution. We're going to simply just simplify it. It's just going to be In this case, 2 cos 2 pi u over m plus v over n, as for this first two, plus 2 cos 2 pi u over m minus v over n. Now I'm going to factorize out 2, which is going to leave us with 1 over 6. That's going to be the final answer. Now moving on to the last one, the last neighbors. Those are the neighbors at this point: 1, 2, 3, and 4. So their points are 2, 0, minus 2, 0, 0, 2, and 0, minus 2. Let's be 1 over 12. So this is going to be the answer. Now the final value for h u of v is simply going to be the addition of all of what we got. So when you add everything, this is going to be your final answer. Now the second question says we should prove that this is a low pass filter. So at low frequencies, that is when u is equal to 0 and v is equal to 0. So we're going to find h at 0, 0. The cos of 0 at every point is 1. So it's 1 over 6 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. That's 6 1. So it's 6, which will be equals to 1. This filter is going to allow all low frequency components to pass at full strength of 1. Now let's check for at high frequencies. At high frequencies, right, u is going to be equal to m over 4 and v is equals to n over 4. U in this case, u over m is going to be equal to 1 over 4 and v over n is going to be equal to 1 over 4. Now if we substitute this back into the equation, cos 2 pi times 1 over 4 is basically equals to 0, plus 4 pi times 1 over 4, that is in these cases going to be equals to minus 1. So it's going to be minus 1 minus 1, cos 2 pi times, in this case, 1 over 4 minus 1 over 4. That will be cos 0. Again, cos 0 is 1. And in this case, it's going to be cos 2 pi times 1 over 2. Actually, so it's going to be cos pi. Cos pi is equal to negative 1. So if we're going to solve this out, it's going to be h u of v is equals to 1 over 6. That will be 0 plus 0 minus 1 plus 1 minus 1 minus 1. The final answer for this is going to be equals to minus 1 over 3. You can see that high frequency components are not going to pass this filter because they have extremely small amplitude. Their frequency is basically 0. So that's the final answer. Thank you for listening. Anything you don't understand, don't hesitate to ask in the comment section. Thank you so much.